Hello, let's solve this series. Given s equal to 3 by 2 factorial plus 8 by 4 factorial plus 13 by 6 factorial plus 18 by 8 factorial plus and so on. So let's find the value of s. So let's start. As you can see in the numerator, you can see the difference between the terms are 5, right? 3 plus 5, 8, 8 plus 5, 13, 13 plus 5 is 18. And in the denominator, everything is in an even number factorial, 2 factorial, 4 factorial, 6 factorial. Right? There is one more interesting thing about the numerator part is everything is 2 less than 5 and 10. As you can see, 3 is 5 minus 2, 8 is 10 minus 2. Similarly, 13 is 15 minus 2, 18 is 20 minus 2. So let's write s equal to the denominator part is 2n factorial. It starts from summation n equal to 1 to infinity, right? The first term in the denominator is 2 factorial. If n equal to 1, it will be 2 factorial, right? What about the numerator? Let's write phi n. If n equal to 1, this will be 5. To get 3, we need to subtract 2, right? This is the nth term for the series. Now let's solve for this. Now s equal to, let's separate this summation 5 into summation n equal to 1 to infinity n by 2n whole factorial minus 2 into summation n equal to 1 to infinity 1 by 2n factorial, right? Now this can be written as summation 5 into sorry s equal to 5 into summation n equal to 1 to infinity n by n factorial can be written as gamma of n plus 1, right? If 2n factorial can be written as gamma of 2n plus 1, right? This is, write it as it is, which is summation n equal to 1 to infinity, which is 2n whole factorial, right? Now you might have read this formula, right? Gamma of n plus 1 can be written as n into gamma of n, right? Here n value is 2n, fine. Then s is 5 into summation n equal to 1 to infinity n by, this can be written as gamma of 1 plus 2n is 2n into gamma of 2n minus 2 into summation n equal to 1 to infinity 1 by 2n factorial, fine. This n will get cancelled and you can bring the 2 out of the summation, which is 5 by 2 into summation n equal to 1 to infinity 1 by 2n minus 1 factorial, right, minus 2 into summation n equal to 1 to infinity 1 by 2n factorial, right? Now this case, let's solve this case. How does it look like? Let's expand this summation. This is i1 and this is i2, fine. Now i1 is summation n equal to 1 to infinity 1 by 2n minus 1 factorial. If n equal to 1, right, if n equal to 1, 2 into 1 minus 1, 0 factorial, which is 1, plus n equal to 2, 2 to 4 minus 1, 3 factorial, plus n equal to 2, done, right? N equal to 3, 3 to 6 minus 1, 5, 1 by 5 factorial plus 1 by 7 factorial plus and so on. What about i2? I2 is summation n equal to 1 to infinity 1 by 2n factorial, which is 1 by n equal to 1, which is 2 factorial plus 1 by 4 factorial plus and so on, fine. Now this looks like sine and hyperbolic functions, right? which is, let's write it down, sin hx is x plus x cubed by 3 factorial plus x power 5 by 5 factorial plus x power 7 by 7 factorial and so on. Fine. Now if x equal to 1, then this is sin h of 1 is 1 plus 1 cube is 1, 1 by 3 factorial plus x power 5, which is 1 power 5, 1 by 5 factorial plus and so on. So I1 is, that is I1 is sin h of 1, sorry, hyperbolic function, sin h of 1. Now the other function cos hx is 1 plus x square by 2 factorial plus x power 4 by 4 factorial plus x power 6 by 6 factorial plus and so on. Right? If x equal to 1 here, then this will become cos h of 1 equal to 1 plus 1 square is 1 by 2 factorial plus similarly 1 power 4 is 1 by 4 factorial plus and so on. As you can see, I2 is, it starts from 1 by 2 factorial, right? Then cos h of 1 is 1 plus I2, right? Then I2 is cos h of 1 minus 1. Now finally, S is 5 by 2 into, where it is, 5 by 2 into I1 minus 2 into I2. 5 by 2 into I1. I1 is sin hyperbolic of 1. Fine. Then the I2 part is minus 2 into I2. Minus 2 into I2. I2 is cos h of 1 minus 1. So finally this S is 5 by 2 sin h of 1 minus 2 cos h of 1 plus 2, right? You can write the full series, which is 3 by 2 factorial plus 8 by 4 factorial plus 13 by 6 factorial plus 18 by 8 factorial is 5 by 2 into sin h of 1 minus 2 cos h of 1 plus 2. Fine. This is the result.